Hey, hi all. You guys can hear me, right?
Yes.
Okay, thank you. Thank you very much. Okay, I think last time where did we left? We just left at some introduction to some CMake and how do we compile applications which are having more than one CPP file or C file, how we can move them to a source folder and how we can move them to some includes to some include folders and compile them. So that's what we covered just to introduce you to CMake. That's not an end. So we will explore more about CMake later on when we get into actual creating shared libraries and linked libraries. Okay. So we'll resume back to C++. Okay. Today we'll just cover function overloading. That should be fine. Okay. Any questions you guys have from last class? If you okay, I'll take this as a no. Okay, you guys can see my screen, right? Okay. So what I wanted to cover today is function overloading. Function overloading is one of the concept in C++ which is not there in C, wherein you can use the same function names and you can pass different arguments to achieve whatever that we needed. Okay. So if you see in this example, we are just have written just a small function by name add-ins, which will take two arguments. Okay, and it will just add them and print the sum of it. Okay. Similarly, I have one more function which I've written like which takes more than two arguments and does the same, adds all of them and prints the result. Okay. So the concept here is how C++ achieves it. Okay, how C++ achieves it is what matters for us, and what are the rules that it needs to we need to consider, or uh, or a compiler considers in identifying a function, like how this guy determines that he should call this, and how this line will be decoded to call this. So this for that we have a couple of rules or couple of pages we can go through wherein they have mentioned like what are the rules to be considered for understanding them. So okay, first we can go through the concepts of name mangling. I'll add this reference links to this code. Okay, so a name mangling is a technique used to convert a functions into a unique identifiers. Okay, so that uh, it can map the code to the corresponding unique names. Okay, so maybe I'll repeat. So function name mangling is a technique which is used to convert any of the pre-declared identifiers or function names into some unique names so that it can map the code functions, I mean the functions that you have written into the actual one. So if you see this link, right? So they talk a lot about name mangling, but for C++, how it does is they have given we can go to those three simple functions. Okay, so this is a function which doesn't take any arguments. Okay, so this is the same function with the same name which takes one more argument. Okay, now you have one more function by name g, which is similar to f, uh, and it is also not taking any argument. Now, how this will be converted? How will this will be converted is See, then the name mapping will be converted into this format. So you have a function f, so it will add an underscore before to it, and based on the arguments that it takes, right? Based on the arguments that it is taking, it is going to add what type of argument that it has taken. So here it is not taking any argument, so it has type converted it into so it is assuming it is as void, so it just converted the name as int of int is a return type, and underscore double two underscores followed by function name, followed by one underscore followed by the first parameter that it's going to take, and it continues. So as many parameters that it has, it will have the it will keep on adding it. Now if you see the second one, which takes an argument of type int, it has added an underscore I. That's how these two are differentiated. Like these two functions are differentiated. That's how. Okay, I hope I'm able to explain you guys on this. So similarly, if you look at our code, how this will be converted would be like this would be converted to this is how this will be converted into, and the same thing here with just one less argument. Okay, this is a concept which is there in C++ compilers. You don't see this in C. Okay, so that's how C++ compilers is able to offer you function overloading concept with different arguments types. So am I clear on this? You guys have any doubt on this? Okay, so we can test this how it has been actually achieved. Okay, I hope you guys are there, right? I'm not. Okay, so
Yes.
yeah, so same function overloading. It's a small function, so I'll just make the directory. See, uh, I have called a function. The what was the first one? Okay, so first function is int of 10 of 2, and the second one is a sum of 5 plus 6 plus 4. Now, as we were thinking, as we explained, this was supposed to call this, and what is the content? It just printed this, so it just added this and it printed. The second function will take 3 arguments, and it is supposed to print this. This is what it does. I hope I'm able to explain this. You guys want me to push this so that you guys want to test it, or I think most of you would know this. Okay, so who is not able to unmute? I'm not sure. So you can type in your questions. So we'll see. Sakal, I will see if you have any questions on this. Okay, and well, go through some few set of rules on this. So the name mangling, I think there are a lot of other things as well, like how name mangling is done for namespaces, classes, and all. So this maybe we'll see later. But for us, we are covering this function overloading. So for this is what we should see. So this is how it get converts. Go through this. So next, maybe I'll paste this as an example in our source code. Okay. So this is how it behaves. So it saves. I'm just gonna save it. Okay. So next one. So there are certain rules. We'll just uh, go through that. We don't want to. It's just a refresher for you guys. Okay. So the another link is like from Microsoft. You can just see the rules, or like how what what does the compiler actually considers before identifying the right function. So does it consider any return type? Nope, it does not consider the return types. It does not consider the return type. Like, so just because if I change it to void to int doesn't mean that it is going to call the actual, and I put here as int is equal to something, and if I make it int, okay, it would not. So this is, we don't call this as overloading. So this will not be called as overloading. So the compiler will still not be able to which one is what. This is one. And number of arguments, I think we have seen the compiler will definitely consider number of arguments, because based on that only the names will be given. As we see, the names for this function will be converted as this. That's how it does. And type of arguments, obviously the type, whether it's int, character, or double, the corresponding names will be added. So if you see, for int it adds something like underscore I, for character it will add something like C, and for double it would add something like D, and goes on. So that's how the unique names are generated by the compilers. Okay. Now, presence and absence of ellipse operator. So this I'll kind of cover in the next example itself. So rest is not mandatory. I think they all we will cover later on. So okay, it's the same now. An exact how it actually finds a same function, like it's in whether the function the converted name has the same match or not. A trivial conversions has performed. Okay, now what to do if, what will happen if you are passing a double? Let's see. See, so we were assuming, so we just passed 10.2, which is a double. Okay, but the function took the function just takes only of type ints. So no matter what you pass, it has down converted into this, and it will use it. So only when you declare it as specifically the exact data type, right? So you will not see the actual results of this. Okay, see. So if you see, by just changing the data type to double, we are able to achieve like whatever the addition that we wanted to do uh, on the whole series, right? We are able to achieve the actual fraction values also we are able to add. But only thing is the data type should match. Yeah. Okay. Now one more part is, what if you pass something like ASCII value as C? Let's see what happens. It just compiled. So, but it gave us a different value. Okay. So what does this mean is, so if you see in the rule, uh, an integer promotion was performed. So mean what it means is, so though you are passing a character here, right? But the data type here is int. So can the content of character sit inside int? Okay, this is what compiler will look into. If it can sit, so it will try to accommodate it. So I think that's what they said. Integral, and integral promotion will be done from the compiler. So it will try to convert this C. So if you see what is it C, the what is the equivalent value is 99. 99 plus 2 is 111. Okay, so 99 plus 2 is 100, I mean 101. I think that's what we got here. Okay, so that's another one. That's I'll add it to the exam. So just try to, you will see if it is still valid. It is still valid. The It is able to add two ints. It is able to add a character and an int. It is able to add three ints. So it's just one function which is able to do. I mean, it is one function overloading. I mean, with using one function name, it is able to identify which function to call. So now, if you see here, C comma 2, it falls under sum of 2s, which is nothing but this. So for this, what is the function that it chose was this, and it just called it. Okay. So that's how that's how the overloading was achieved here. Mean we try to match. Okay. Next, a standard conversion to desired argument type exist. User defined convention. Okay, this is for structures and classes and all. When you declare structures and classes. So how do they match each other? Like base class, parent class, all this comes here. Next one is ellipse one. Okay, I'll take up the ellipse next. So far in this the very minor concept, any doubts? Okay, so I'll take this as a no. Okay, next one is next. Can go through Vardiac function templates or function templating. Okay, so uh, so assume you want to write a function wherein it just takes as many arguments as it wants and it just prints them. Okay, so like you would have seen something like uh, a printf, right? You are trying to write something like a printf. In C, you would have seen a code which is similar to printf, which takes uh, some string chars and followed by as many type of character equivalents for it, right? Okay, so now what this will do, this will concatenate it, this will take the character format that you have mentioned here. Okay, like percentage %s, percentage %d, whatever that you have mentioned, it will take. And based on that, it will look for the arguments that you have passed, and it will keep on adding them and goes on and on. So that's how you would it would have achieved in C++. Okay, so how it basically does is this is for Microsoft. Uh, let's see. Okay, so the printf equivalent code you would see, right? It's a simple printf code. It's a const star star followed by triple dots, which means it's going to take characters only going forward. So what it will do is C provides. I think most of you would have used this VA list or VA start. What it does is it declares an indefinite arguments list, and it will take this format and it will iterate through them and try to add them one after one and just print them. This is one of the simplest printfs that would be available. I think this is some different way someone has written. Generally, what it does is VA starts, then they would put some VA printf, and they will add all the strings, and they would try to print the result onto a console. Okay, but whereas uh, how we can write that in C++, like no matter what type of arguments it is, right? You don't need to put that percentage %s, percentage %d. So all those part you don't need to put. Okay, you can just write a some dummy function using which can take different arguments and you can print them. So for that, what we have is for function templates. So function templates means so you just define a function, okay, which will do the uh, and write the skeleton of what it does, and you pass some type names as an arguments, okay, using which it takes different types of no matter what type of data that you pass, whether you pass int, double or any character strings, it will try to do the same operation on top of it. Okay, now if you see here what this function does, it is taking print it is taking an integer, and what it does is what it does is that it takes the first arguments. If you see type as var, okay, now you do what you want. You just try to print the first thing that you have done, and then a recursive. Actually, this actually use the concept of recursion, and what it does is then you call the printf print on the rest of the arguments that you are passing. So this var2, what it does is now it again calls the same print function with the rest of the arguments. Okay. Next, what it does is next it will call the same function again with the rest of this. So and this goes on and on until it reaches the end. So at the end, what it is, what they in this example they have written is I'm an empty function. I'm called at the last. You can actually remove this content. So maybe you can keep it for our reference. So whatever the if you see if you see our code, what you have written 1, 2, 3.1, pass me any number of arguments and I will print. This is the content we wanted to print. So this is a syntax for it. That's how you written, and it just prints it. Okay, it's in, as you have passed it, it prints it. Now the most important thing is now understanding that definition of it. Okay, how do you define a function template class syntax? Okay, so when you want to declare a syntax for a function, right? First thing that it's mandatory is you define you use the keyword as template. Okay, you always use the keyword template first, then how many arguments that it takes. Like if it is taking more than one argument, you can specify what are the exact number of arguments it is taking, or else if you don't know the arguments, you can use this other way of putting an ellipse. So we'll go through a simple ones. I want to introduce you to the bigger ones. Print to what it does is it takes var1, var2. Okay, what we can do here is so what this guy is doing is it just compiler no matching function of int and char because we have mention the both the types to be same. So we can remove this. Okay. So it is, so now you see if the types matches T1 and T. Okay, both the types should be same. So I have given both as integers only. Okay, now let's see what it does. It just prints whatever that you have passed 3 and 5. Okay, so this is a typical syntax to write a small function templates. You just write the function and you say what type of I mean you are just giving some dummy name to a data type that you are passing. Here the data type that you are passing is going to be of type T, and this will be your variable names. Okay, so here you declared, as I am assuming, a type name as T and use it henceforth. Okay, so whenever it sees variable one, it will replace it with, it will assume that data type that you have passed is of type T. And what is this T? T is nothing but what you have passed here. Here, if you see, it is int. Here, if you see, it is int. It goes like this. So, any questions on this one? Okay, not getting any questions. So, you guys can hear me, right?
Yes, yes.
Yes.
Yeah. So, okay. Uh, okay. Yes. Okay. Next one is you can hardcore a data type itself. So you can say it's not a variable. Okay. You can actually hard code a data type. Matlab, so you have writing a function
Sir,
and you,
one thing,
Mhm.
sir,
Yeah, go ahead, sir.
sir, see, can you, yeah, can you give one simple program and can you explain? Because inside of means in middle of the program you have explained, right? So we are not able to understand that see out how is it working like that. So you only changed
Okay,
and tell no. So that's why if you give the
okay,
simple program and inside that you have to explain means I can understand.
okay. I'll go through it. Okay. Here I took it. I'll push this one. Maybe then you can do this. Okay. So why we would use function templates and all are like you are trying to run some algorithms like sorting or you are trying to delete an item or in a list, or you are trying to add an item into a list, right? uh, so and the for whole of that, the concept is same, like you enter sorting, what we do, we just add to, you try to find which is the smallest and exchange the data, right? So that way of code we can write. Okay. So for KLL, where I have them, let's write a program to sort, or this should be, actually this should be enough. Okay. Okay, let's write a sort program itself.
The second one is character uh, string array or the character array only?
It's a characters string matlab you would see at the end null, right? It should have been
Okay.
declared as std string. So it's already sorted. We'll see some. We'll make some. See whether we can do. Return the code. It's sort, or we'll make it this something like this.
The smallest zero f
Smallest,
means smallest function name, right?
smallest mean just smallest element in this array. I just changing it. Uh, Let me write this function.
Okay.
Okay. Assuming with generally it should be t min, assuming everything is greater than 0.